If gold were truly rare, why do some locations keep producing it year after year while others, just meters away, never yield anything? Geology already knows the answer. According to data compiled by the United States Geological Survey USGS, over 90% of all gold ever mined did not come from random surface finds. It came from predictable geological systems that repeat the same patterns across the planet. Gold does not appear where people expect it to. It appears where movement stops. Deep underground, gold begins its journey as microscopic particles often less than 1 micron in size carried by hot, pressurized fluids moving through the Earth's crust. These fluids typically travel along fractures and fault zones at temperatures between 250 and 400 degrees Celsius. At this stage, gold is invisible. It has no shine. It has no value. It only becomes meaningful when something interrupts the system. A sudden drop in pressure, a chemical boundary, a fracture that creates resistance. When that happens, gold precipitates out of solution and settles into the rock. This process is not theoretical. It has been documented in every major gold-producing region on Earth. In South Africa's Witwatersrand Basin, which has produced over 30% of all gold ever mined, gold occurs almost exclusively along specific ancient sedimentary structures. Not randomly. Not even. Only where conditions allowed gold to stop moving. In Nevada's Carlin Trend, responsible for more than 10% of global gold production, gold is so fine it cannot be seen with the naked eye, yet it follows the same structural controls again and again. Different continents, different ages, same rules. This leads to a critical realization. Gold is not discovered by effort. It is revealed by positioning. This is why two prospectors can work the same river, using the same tools, and get completely different results. One digs harder, the other digs smarter. Because the deciding factor is not how much ground you move, but whether you are standing on a system that ever allowed gold to stop. Industry studies show that over 70% of economically viable gold deposits are structurally controlled. That means gold exists only where rock failure created pathways and traps. No structure, no gold, no matter how promising the surface looks. This also explains why maps often mislead beginners. Maps show where gold was found. They do not show why it stayed there. Once the easy gold was removed, the structure remained untouched, misunderstood, and often ignored. Gold does not follow stories. It does not respect claim boundaries. And it does not respond to hope. It responds to physics. And physics does not change. Before rivers carried gold, before erosion exposed it, before humans ever arrived, gold had already been placed deliberately by forces far beyond chance. So before we ever talk about rivers, pans, or recovery methods, we need to understand the foundation. Because if you don't understand where gold is allowed to exist, every search becomes guesswork. If gold follows structure, then the next question becomes unavoidable. Why does gold stop in some rocks but pass straight through others? Because not all rock behaves the same under pressure, water, and time. From a geological perspective, most rock is simply a pathway. Gold passes through it without resistance. Only a small percentage of rock ever becomes a trap. According to structural geology studies used by major mining companies, less than 5% of exposed bedrock surfaces have the physical characteristics needed to retain gold over long periods of time. That means 95% of rock you see is irrelevant no matter how promising it looks. So what separates the 5%? The answer lies in damage. Gold prefers rock that has been stressed, fractured, folded, or chemically altered. Smooth, intact rock is actually a bad sign. It allows gold to keep moving. Rough, broken rock does the opposite. Fractures create interruption. Folds create pressure changes. Irregular surfaces create microzones where energy drops. When water or mineral-rich fluids lose energy, gold reacts instantly. It presses downward. Unlike gravel, gold does not roll. Unlike sand, it does not drift. Because gold is soft and dense, it deforms under pressure and molds itself into the smallest available spaces. This is why experienced prospectors focus on bedrock cracks, not gravel depth. In placer environments, studies show that over 80% of recoverable gold is found within the first 15 centimeters above bedrock, or directly inside bedrock fractures. Going deeper into loose material often produces nothing, because the real decision already happened at the rock's surface. Another critical factor is orientation. When fractures run across the direction of water flow, rather than parallel to it, gold retention increases dramatically. Water cannot maintain velocity across these interruptions. Microeddies form. Pressure drops. Gold sinks and locks in place. This is why two cracks that look identical can behave very differently, one aligned with flow, one cutting across it. Only one becomes a trap. Chemical alteration matters too. Iron-stained or oxidized bedrock often signals past hydrothermal activity, the same systems responsible for introducing gold in the first place. Oxidation roughens the rock's surface at a microscopic level, increasing friction. Gold adheres more easily and escapes less often. In many historic gold districts, the richest placer gold is found directly downstream of oxidized, fractured bedrock zones not randomly distributed along the river. Then there is clay. Clay is not a trap by itself, but it acts as a seal. Fine clay layers can fill fractures after gold has already settled, locking it in place and protecting it from later floods. This is why some bedrock cracks continue to produce gold decades after surrounding areas are worked out. The trap was never emptied. It was simply sealed. This leads to an important conclusion. Gold does not accumulate because conditions were perfect. It accumulates because conditions failed in just the right way. Rock that breaks, bends, and resists movement becomes valuable. Rock that remains smooth and stable does not. This is why gold distribution appears mysterious to beginners. They look for shine. Professionals look for damage. Once you understand this, the landscape changes. What once looked like random stone starts behaving like a map written in fractures, texture, and resistance. And that brings us to the next layer of the system. Because even the best rock trap is useless without the force that delivers gold into it. Once gold has a place to stop, it still needs a delivery system. That system is water. Water is not just a transporter of gold. It is the oldest and most efficient natural processing plant on Earth. For millions of years, rivers have carved mountains into gravel, gravel into sand, and sand into fine sediment. In that process, everything moves except what is too heavy to keep up. Gold has a density of 19.3 grams per cubic centimeter. That makes it nearly 7 times heavier than quartz and more than 3 times heavier than most common rock fragments. This single physical property determines almost everything about how gold behaves. In flowing water, lighter material stays suspended. Heavier material drops when energy decreases. That decrease does not happen randomly. According to fluvial sediment studies, water consistently loses energy at predictable locations. Behind large boulders along the inside of river bends, beneath gravel bars, and most importantly, directly on bedrock. This is why gold is rarely found floating in loose sediment for long periods. It sinks, it presses downward. And when it encounters resistance, it stops. This process has been measured and replicated repeatedly. In controlled experiments, gold particles settle up to 15 times faster than sand of similar size when water velocity drops. Nature uses this principle constantly. Every flood acts like a reset. Lighter material is picked up and carried away. Heavier material is driven deeper into the same traps. This is why experienced prospectors focus on where water slows, not where it flows fastest. Another overlooked factor is repetition. Gold rarely settles in one event. It is pushed, released, and pushed again, sometimes thousands of times. Each flood removes lighter material. Each cycle drives gold deeper into cracks, crevices, and bedrock irregularities. This explains why some locations continue to produce gold long after they appear worked out. The gold is not replenishing. The trap is simply effective. Biological materials play a role as well. Studies have shown that moss, root mats, and organic debris along streams can trap fine gold particles by friction alone. Over time, these materials act as temporary collection layers, feeding gold into more permanent traps below. Even clay contributes. Fine clay particles settle into bedrock fractures after gold has already arrived, forming a natural seal. Once sealed, gold becomes extremely difficult to remove even during high-energy flood events. This is why some gold-bearing cracks remain productive for decades. The system does not forget. The most important realization here is this: nature does not scatter gold. It concentrates it. Humans did not invent gold recovery. They observed it. Panning works because rivers already did most of the work. Sluices work because bedrock behaves like a natural sluice. Modern processing plants still rely on gravity, density, and flow control, the same principles rivers have used for millions of years. Gold does not respond to force. It responds to physics. And physics is patient. Once you understand how water sorts material, you stop treating rivers as random. They become readable systems. But water alone does not explain everything. Because many gold traps remain active even when the water is gone. At this point, a natural question arises. If gold follows rules, if structure controls its movement, then why do so many people still fail to find it? The answer is uncomfortable. Most people are not reading the land. They are reading history. Gold maps, mining claims, and historical records are often treated as guides. But in reality, they describe outcomes, not causes. A gold map shows where gold was found. It does not show why it stayed there. According to mining industry reviews, over 60% of abandoned gold claims were not exhausted because the gold was gone, but because the easy, visible gold was removed.
What remained was locked in structure that early miners did not understand or could not process efficiently. This is why some locations labeled worked out continue to produce gold today, sometimes more consistently than before.
The structure never changed. Only the understanding did. Another major mistake comes from assuming rivers are the source of gold. Rivers do not create gold. They transport it. The true decision about where gold ends up happens long before water ever touches it, when bedrock fractures, shifts, and seals under enormous stress. Experienced prospectors know this. They do not ask where was gold found before. They ask, could gold stop here? That single question filters out most false leads. This also explains why beginners often chase surface indicators: sparkling sand, visible quartz promising gravel. But surface signs are temporary. Structure is permanent. A flood can erase surface clues in hours. Bedrock traps can hold gold for millions of years. Even geological maps, while useful, have limits. They show formations, fault zones, and rock types, but they cannot show microfractures, texture, or how a specific rock surface behaves under flowing water. That information cannot be printed. It must be observed. Professionals spend more time studying exposed bedrock than moving material. They pause. They trace fractures with their hands. They watch how water behaves across stone. This patience is not romantic. It is efficient. Field studies show that experienced prospectors often work less ground, yet recover more gold per hour, simply because they focus on confirmed structure rather than possibility. Gold does not reward speed. It rewards alignment. Once you stop trusting maps alone and start trusting physical evidence, gold hunting stops being random. It becomes predictive, and this shift has consequences far beyond prospecting. Because the same mistake, trusting history instead of structure, appears everywhere people search for value. Which brings us to a deeper connection. Because gold is not just a metal, it is a lesson. At this stage, it becomes clear that gold is more than a geological curiosity. It is an economic anomaly. Gold is not the rarest material on Earth. In fact, several gemstones are far rarer. Diamonds, for example, are estimated to occur at 1 part per billion in the Earth's crust.
Platinum is even rarer, with an average crustal abundance nearly 30 times lower than gold.
And yet gold consistently holds more universal value. Why? Because value is not defined by rarity alone.
It is defined by availability, durability, and trust. Gold's unique position comes from a combination of physical properties that no other material shares.
Gold does not corrode. It does not oxidize. It does not decay. A gold artifact recovered from a 3,000-year-old burial site is chemically identical to gold refined today. No gemstone can make that claim. Emeralds fracture. Rubies crack. Diamonds chip under the right conditions. Gold bends instead of breaking. This softness, often misunderstood as weakness, is actually an advantage.
It allows gold to deform under pressure, embed itself into rock, and remain trapped for geological time scales.
The same softness makes gold easy to shape, divide, and verify critical traits for money. This is why gold became a global standard independently across civilizations. From Mesopotamia to China, from the Roman Empire to pre-Columbian South America, gold was chosen not because cultures communicated but because physics dictated the same outcome. Another critical factor is energy cost.
According to modern mining data, producing 1 ounce of gold requires moving an average of 30 to 50 tons of rock.
For gemstones, the ratio can be far lower. This embedded energy cost creates a natural price floor. Gold is expensive because it is difficult to release. No technological breakthrough has changed this reality. We can process faster. We can refine cleaner. But gold extraction remains energy-intensive, slow, and constrained by geology. This is why gold behaves differently in times of instability. When financial systems shake, gold does not surge because it promises growth. It holds because it limits surprise. Gold is not exciting. It is reliable. This reliability contrasts sharply with many gemstones. Gemstone markets are opaque. Pricing is subjective. Supply can change suddenly with a single discovery. Gold markets, by comparison, are transparent, liquid, and global. An ounce of gold means the same thing in New York, Zurich, Dubai, or Shanghai. This universality is rare, and it ties back to the same geological truth. Gold forms slowly. Gold resists release. Gold remains where structure allows it to stay. The Earth treats gold differently. So do humans. Which leads to an important realization. Gold's value is not just cultural. It is structural. It emerges from physical constraints that cannot be negotiated, printed, or engineered away. And that is why gold continues to matter even in a digital world. But understanding value is only half the story. Because recognizing value is one thing. Knowing when and where to act on that understanding is another. By now, one truth should be clear. Gold has never been hidden. It has always been exactly where physics demanded it must remain. Deep underground, gold formed where pressure slowed, where fractures created space, where structure interrupted movement. Later, water delivered it. Gravity sorted it. Time locked it in place. Humans did not invent this process. They learned to recognize it. And this realization changes everything. Because once you understand how gold behaves, you stop asking the wrong questions. You stop asking, where is the gold? You start asking, where could gold stop? That shift separates luck from strategy. Gold does not reward speed. It does not reward noise. It does not reward effort alone. It rewards understanding. This is why the richest gold discoveries were rarely made by those who rushed. They were made by those who paused, observed, and read structure instead of chasing signals. And this lesson does not belong to geology alone. It applies everywhere value exists. In nature, in markets, in opportunity. Value does not announce itself. It accumulates quietly, where systems slow down and friction exists. Most people chase movement. Few people study resistance. Gold teaches this lesson relentlessly. It waits in stone, indifferent to hope or excitement. It only responds to physical reality. And physical reality does not care how badly you want the outcome. So the final question is not about gold. It is about perception.
If gold has always followed structure, and structure has always been visible, how much value in the ground, in investments,
and in life has gone unnoticed simply because we were looking for noise instead of understanding. Gold has never been rare.
The ability to recognize where value is allowed to exist, that is what has always been scarce.